So in this Python demo, we'll be going over um, convolutional neural networks. And to start with this, we're going to be pretty much getting a specific data set called the CIFAR10 here. And after getting the CIFAR10 data, we're then going to normalize this data, right? And once we get this data, we then are going to do data augmentation, which specifically here in this section, we're just um, looking more into the images that we are given, right? And in doing so, uh, we're just shifting, we're rotating and flipping the images. We're just trying to analyze and get as much information as we can to create an accurate model, right? Because more information is the best, right? And then here we're just fitting the train images right here. And then here we're just creating a convolutional model here with multiple blocks, as we can see here. And um, basically, in each, as we can see here, that in each convolutional uh, block here, we're increasing the filter size. Like this one's 64, this one's 128, and this is 256 here, right? And by doing so, we're just able to capture higher level features. All right. And so basically, once we um, create more filters, right, it makes it more easier to break down the data set. At least that's how I understand it. Um, and so here, with in here, we're just going to combine all the features together and create a like a 1D vector of all the dense layers, and then we're just gonna stabilize with this batch normalization here, right? And and then here, we're gonna be using a method um, which just allows us to improve the convergence and avoids any sort of overshooting here. All right, and pretty much with a smaller uh, epoch, we're going to be like returning it, and then as we increase the epoch value, then it's just going to be finer tuning it. So again, it's that just means that uh, it just allows us to avoid this overshooting, right? Because this is essentially an exponential of a negative value, creating a very uh, which is just minimizing like the distance in a sense. Um, and then here we're just compiling the model here, and we're going to of course be taking account of its accuracy, right? Which we definitely are interested in. And then here we're just training the model. We're putting in the data and we're augmenting the data, and then we're doing it in steps of 50. Uh, e so epoch is going to be 50 here. And then here we do the test validation, and then we apply um, the the learning rate scheduler. That's what that is, the learning rate scheduler. Um, okay, so then from here we're just evaluating the data, right? We're just getting um, the loss and then the accuracy. And then if we were to apply this code into TensorFlow, right? Um, I've um, already did this beforehand, just because this process takes like probably like 30-40 minutes with a solid computer. So, is there any way of? Okay, so okay, right here, it gives the given accuracy, the loss, and the and other values that we can look at here. But we would see here that our final test accuracy is 90%. So this definitely um, is what we're looking for our model. It's slightly greater than 90, but that's pretty much what we got.